It was just another day in the laboratory. Until... And that was the exact moment I knew I had to do it.
Cause I was born for this, yeah. Born to roam, born to ride. Keep on flying till my hands touch the sky.
There was only one problem though. I never worked on a two-stroke before. But that never stopped me, so I started researching. And here is what I've learned. First of all, two-strokes engines are way simpler, with no valves, springs, or complicated heads. Okay, but you're probably wondering, how does a two-stroke work then? Well, let me show you something. This is a reed valve. It's basically a one-way valve that lets air-fuel mixture enter the crankcase. When the piston moves up, it creates suction that pulls the air-fuel mixture through the reed valve. As the piston comes down, it compresses the fuel mixture, pushing it through the transfer ports inside the cylinder. So now that we understand how a two-stroke engine works, it's time to design one from scratch. But first, let's take some measurements.
First step wasted, waiting for your ticket. Step 2, all you, now you're just a minute, your brain just gotta
Hey,
call
cut the
it
music,
like
cut the music. Now that we have all of these measurements, it's time to jump into Fusion and start designing this bad boy. I've started with the crankcase, this being a part that can make or break this engine. A poorly designed crankcase will result in a bad fuel delivery, which leads to low performance or even no start. And this is what I ended up with. It has two transfer ports on each side and a big intake designed with the AM6 reed valve in mind. After printing everything, I realized the mating surfaces between the two crankcases is not perfect, which will lead in loss of crankcase compression and bad fueling. I fixed it though with a bit of sandpaper and some elbow grease. Next step was installing the crankshaft. This is the same crankshaft I'm using on my high-performance 3D printed 4-stroke engine. It was made by PCBWay and it performed amazing so far. Once again, a big thank you to PCBWay for all the help. With the crankcases put together and all the bolts tightened, with the crankcase ready, it's now time to start working on the cylinder. So I designed and printed a cylinder body, but inside of it we are gonna need a cylinder sleeve that's a little bit more heat resistant. And for that I'm gonna use this stainless steel pipe that I've cut to length. After that I printed the template to know exactly where the intake and exhaust ports are gonna be. Got everything marked up and ready for drilling. And after some practice and a couple of failed attempts, I ended up with this. The cylinder has a 58mm bore, 4 intake transfer ports, each with its own hole inside the cylinder sleeve. Now that we have our cylinder ready, it's time to print a piston that's gonna fit inside of this bad boy. So I got it designed, printed it out of carbon fiber reinforced nylon for a better heat resistance, I used O-rings for compression rings, and I got it installed. And after installing the cylinder and the head, this is what I ended up with. I also got all the bolts torqued to spec and I installed the spark plug. Speaking of spark plugs, now that we have everything put together, I think it's time to start working on the ignition system. And for that I'm gonna use this 12 volts coil pack that's gonna be controlled by this 3D printed distributor that I've installed around the crankshaft using a 3D printed holder, and to tie everything together we are gonna have a knob on the crankshaft that's gonna control the spark timing. The next thing we are gonna need if we want this engine to start is a proper fuel system. This is the injector I'm gonna use to make sure we have a good fuel delivery. It is going to be controlled by this nano controller that's gonna take the signal from the crankshaft using a Hall sensor. If you want to see a more detailed explanation of this system, I have a video explaining everything on my channel. Next I designed and printed an intake that has a slot that holds the injector at the right angle and also a throttle flap. Next up I installed the reed valve and the intake manifold. Now that we have an intake, it's time to focus on the exhaust side of the engine. In two-stroke engines, the exhaust does more than just exhausting the burned gases. It actually helps pushing back any mixture trying to escape the cylinder. The shape of the pipe sends pressure waves that trap the mixture inside the combustion chamber. That is called exhaust scavenging, and that's why two-stroke engines make so much power. So I designed an exhaust system that's capable of doing all of that, and I got it printed out of carbon fiber reinforced nylon, and I got it installed on the engine. With the exhaust on, I got all the other electronics installed, and I think we are ready for our first testing session. Well, our first testing session was definitely a success. We found out that we have a good design, first of all. So the fuel is delivered inside the cylinder. We had some signs of life, but only on starter fluid. That means something is off with my fuel delivery from the injector. In the crankcase, the fuel is delivered through the ports properly. It enters the cylinders, it ignites, we have spark. So I'm gonna have to refine the system a bit. I'm gonna open it a bit more. I'm gonna give the injector a bit more opening on each pulse of the Hall sensor. I'm gonna do that, and we are gonna jump in another testing session. It actually started! And it sounded amazing, guys. Let's hear it one more time. It still has some fueling issues though. It started on starter fluid, it ran for like 6 seconds, so that's definitely a success. We still have a fueling problem, so I'm gonna go back to the basics and try to start the engine using a carburetor. So I printed the new intake manifold and I got the carb installed. So let's see if the engine is gonna run for longer. Unfortunately, I had no luck with the carburetor. I tried adjusting the fuel mixture, the idle, I tried everything. So I decided to remove the carburetor and try running the engine on starter fluid one more time. And this is what happened. Well, we had two amazing runs. This thing definitely exceeded my expectations. It sounds amazing in person. I'm not sure if the camera can actually capture that, but the engine is almost out of compression. I think it's time to open it up to see what actually failed. I started by removing all the head bolts. And when I removed the head, this is what I found. That's a lot of buildup. This looks exactly like the buildup that happened on my 4-stroke high-performance 3D printed engine when it completely melted the piston. Here we can actually see the exact spot where we were losing compression. It's also visible on the cylinder body. Now let's remove the cylinder to see the state of the piston. It definitely has a lot of heat damage on the top, and this is where all the buildup on the head came from. The rings, the cylinder and the crankshaft had no damage. There we have it, a fully functional 3D printed engine that actually ran. And ran pretty good if you ask me. I wanna say a big thank you to all my Patreons. If you would also like to see more of these projects being made, make sure to subscribe and check out my Patreon link in the video description. Thank you for watching guys and see you in the next one.